can manage. Any graph, not only this, any graph. So this is a pressure. This is a volume. So let's this pressure be P. This is 2P. This is V. This is 2V. Okay, the path is like this. So I'm interested in what like now? Equivalent graphs. This is a pressure versus volume graph. I want PT graph, VT graph, and any other thing, Euro graph or any other thing. Okay, how to plot this equivalent graphs? First of all, what we should know, like 1 mole of this is a monoatomic gas and 1 mole is what I'm choosing. So at various points, this one at this various points, what we'll calculate the temperature. So it'll be applying ideal gas equation at 1. PV equal to nRT1. So this is PV equal to RT1 or T1 equal to PV by R. So this is a temperature of gas. We'll call this as say T naught or T, any of the symbols. Or let's go for, it'll be easy for us to compare. PV equal to nRT graph. So what are the pressures there? P naught, V naught. So that T1 will call T naught. Similarly, let's apply ideal gas equation at 2. The first problem I'll show in detail. The pressure there 2 P naught, volume V naught, number of moles 1. So R T2. So what is T2? 2 P naught V naught by R. So therefore this will be 2 T naught. At 3. Pressure is how much? 2 P naught. Volume is how much? 2 V naught. So R T3. So what is T3 equal to? 4 P naught V naught by R. So therefore this should be 4 T naught. At 4, pressure is P naught, volume R T4. So then this should be 2 P naught V naught by R. Okay, let's have the temperatures. It'll be easy for us. So temperature is how much? T naught, 2 T naught, 4 T naught, 2 T naught. So first what I'm asking, the PT graph. So look at the y-axis, the pressures. P naught to P naught is there. Look at the temperatures. So minimum is T naught, or select a T naught and 4 T naught. So therefore now you choose an axis. I want PT graph. Pressure versus the temperature. So you break up like this. So what are the values of pressure? So I do have P naught to P naught. Here it is T naught, 2 T naught, 3 T naught, 4 T naught. You should not remember, just learn the methodology. So what we are plotting, pressure versus temperature graph. Identify points. At point 1, what is the pressure? P naught T naught. So here pressure P naught T naught. Don't plot any curve. Then at 2, what is the pressure? 2 P naught, temperature 2 T naught. So 2 P naught, 2 T naught should come here, the point. Roughly, later on we'll try to do correction if the curve is not suitable. 2 P naught, 4 T naught. The point will be here. For 4, P naught, 2 T naught, P naught, 2 T naught. Okay, let's go for now the curve. The curve has to be brought here. Okay, what is 1, 2? Anybody 1, 2? Isochoric process, no? It is in isochoric process. What be constant? Volume will be constant. And PT graph, straight line passing through origin. So there's a straight line passing through origin. What is 2, 3? Isobaric process. 3, 4, isochoric cooling, straight line passing through origin. And the curve should be such that should be straight line passing through origin. No, put arrows. Okay, got this. So this was the PT graph. It's over. You should not remember, methodology is what you have to learn. No, PT graph got over. Now what we have to, we'll go for VT graph, volume versus temperature graph. Sir, I'll plot temperature versus volume. It's left to you. On y-axis, I'm taking volume. This is a temperature. Now, what are the volumes? V0 and 2V0. Temperature as usual. T0, 2T0, 3T0, 4T0. Again, what is the method? Just identify the points. V0, T0. Okay, first point. Then one next 2P0. So volume V0 and T0. V0 and 2T0. Okay, 2 will be here. Okay, after this point 3, 4T0 and 2V0. Okay, this is a point 3. Point 4, 2V0, 2T0. This is a point 4. Okay, what is 1, 2? 1, 2 is what? Isochoric process. Isochoric process, how do you represent? Straight line passing through origin. 2, 3, what is 2, 3? Isobaric process. Isobaric process in VT graph. Straight line passing through origin. 3, 4, isochoric. 4, 1, again isobaric. So again, it's a straight line passing through origin. Okay, graph may not be exact. I'll okay, I'll redraw it so that because we are not drawing up to the scale, no, it will be like this only. Okay, we'll reset it. Let's come to know. This is, we'll redraw the scales, all other scales also will redraw it. Yeah. 3T0 will not be there. In exam, you need not to go, nobody will ask you to draw, no? Only you have to identify the graph. 2T0, 3 0 you mentioned somewhere. There's a 4T0. So there's a point 2, 3, 4. The curve will be like this. Okay, fine. PT graph and VT graph. If you want, you can go for also Euro graph also, intensity versus density graph. Later we can see. Now there's a basic, so they'll give equivalent graphs. So there's a method what a student has to follow. Let's take the next one. Okay, there's A, B, C, D. He has not given anything volume pressure, just is asking plot the equivalent PT graph and VT graph. So what is this? This isothermal expansion. This is also isothermal. Isothermal compression it is. So what is this process will be? Isochoric cooling. And this will be isobaric heating. Sir, how do you can say, I think this is what student has to learn here. Nothing big. Pressure constant. So if pressure constant, what happen? Isobaric process. Pressure constant, volume increase, temperature increase. So it will absorb it. Isobaric heating. Isothermal expansion. Volume increases, isothermal expansion. Volume constant, pressure decreases, temperature decreases. So isochoric cooling. Isothermal compression. Temperature constant and volume, what will happen? Will decrease. So isothermal compression. Okay, it's not giving any P naught, V naught value. Rough graph is asking, a rough graph. Okay, I'll begin first with the pressure versus temperature. So in isothermal process, what should happen to pressure? Pressure must be constant, no? So TB, okay, TB should be equal to TC. Sir, how do you can say? Because that's what in isothermal process, temperature will remain constant throughout the process. Similarly, TD is equal to TA. Will I agree? There's a basic idea why, because isothermal process it is. Okay, now we are going to keep this in mind. So what I'm going to plot, pressure versus temperature. No, I think this will be really troublesome because I'm not giving any value. No problem. Okay, let it be. So there are only two values of temperature, no? There are only two values here, TB and TC here. Here TA and TD. What about pressure? Pressure is also having two values, PA equal to PB and TC is not equal to TD because you see PC and PD are there. So three values of pressures are there. Okay, first, what is the isobaric process? Isobaric process should be a constant line, horizontal line it should be. Shall I go for horizontal line? Sir, how do you can plot that one? Rough guess I'm making. Okay, here. So how do you can say temperature increases? So come back to this one. In isobaric process, pressure constant, as volume increases, temperature should increase or decrease. You must really answer this thing. So here I'm going to write TB greater than TA. Similarly, TC greater than TD. I think these are the most important things. And whatever the pressure, PA equal to PB, PA greater than PC greater than PD. What about the volumes? I think all this data is there, no? Let me shift it down. Okay, these are all the informations are there regarding that particular graph. Anybody, can you say about the volume? Volumes, it's very clear, no? VC equal to VD. And VC greater than VB greater than V. I think these things are going to help. Now we are calculating pressure versus temperature. Okay, afterward, path BC, isothermal expansion. In isothermal expansion, temperature will be constant, pressure will decrease. So what should be the curve? The curve should be a straight line, vertical line. Okay, afterwards, CD, isochoric cooling. In PT graph, what is isochoric process? Straight line passing through origin. So now, I'll bring it here. So this is D. And what is DA? Isothermal compression. So pressure should increase, temperature should be constant. If you say I'll remember, then gone. what is the guarantee that what you practice, that question will come? So better what to learn? The method. Okay, this is what happens for pressure versus temperature. Are you getting now? So there's an horizontal line. Huh? I think it must be horizontal line. Finding out. So it need to be always some hydrothermal process also comes. We can plot it here. Okay, now there's a pressure versus temperature graph. Now similarly, volume versus temperature graph is needed. Let's go for volume versus temperature graph. Or temperature versus volume, anything. Let me take on y-axis volume. Let's start with, so how the isobaric process will be AB. Isobaric process in VT graph. Straight line passing through origin. So I'm not very sure. Roughly, I'm plotting the graph. Even myself, I'm not very sure. For volume of gas should increase. Volume and temperature both will increase. So therefore, I'm taking this point as A. This is B. Afterwards, BC is what? Isothermal expansion. So therefore, the curve. What is CD? CD is isochoric process. Isochoric cooling, no? So temperature should decrease, volume constant, temperature should decrease. Look at the curve will be like this. Then what is DA? DA is isothermal compression. Okay, I think luckily we got correct one. A, B, C, and this is D. Getting some idea. So let them give any curve, no? So we can manage. Sir, you are showing only PV. So why don't you take PT graph and show some other thing? Okay, let's do one thing. Next week we'll go in detail. So many graphs will come. So there's just only introduction. D and origin. What is that D and origin? Where I'm joining D and origin? And what is D and A? D and A, no. I'm not joining D to any origin. Look at. D and origin, it's a straight line passing through origin, no, CD. What is the path CD? What is the path CD? Isochoric process, straight line passing through origin. It must be, no, PT graph, VT graph. Isochoric process in PT graph, straight line passing through origin. Your memory should be very, 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 very strong. Huh? Isochoric process in PT graph, straight line passing through origin. Let's go for PT graph. Last one graph, I'll plot it. Please don't remember, learn the methodology to plot the graphs so that you can manage anything.